One of the repetition or looping statement that what we have understood in the last hour is the while statement. Let us once again understand the basic information which is required in these statements are: the first one, the initialization of any of the data that is required for repetition process. While is the keyword, and the condition that what you are going to enforce. Until this condition is true, the whatever the statement which is there, that is called body of the statement, that should be repeated. So the general structure looks like this: while, open bracket, the condition that what you are going to enforce, I less than 10. There is one small example to demonstrate, that is the step 1. If this condition is true, the control goes to steps 2, where there are many statements, step 1, statement 1, 2, 3, like that. All these statements which are placed between begin and end, these are repeated. Once again, whenever after the statement n, the control goes back, that is the step 3, checks for once again the condition. Now you have to observe this condition is manipulated in any one of these statements, so that when you are going to reach to this condition at some time, whenever this condition fails, the control goes to the next statement after the while loop. So this is the general structure of a while statement. Using this, it is possible to develop many interesting programs. That is, if the condition is true, it goes to the repetition of this process and goes back until, if it is no, control goes outside the loop. So let us understand through a small example. We want to print in the output 1, 2, 3 up to 12. This is the, all these values should be printed on the output. How you can start your program? As usual, let us take one variable n, initialized to 1. That is integer variable n, you are initialized to 1. While n less than or equal to 12. Inside the body of the loop, you are having a statement printf %d n. So the value of n initially 1, it prints 1. And then you are incrementing the value of n plus plus. I think in the last class you understood the meaning of n plus plus. It is nothing but n is equal to n plus 1. Instead of writing that, you can also write in the form of postfix form, that is n plus plus. After this statement, because of this n, the control goes back. Now the value of n, previously it was 1, now it has become 2 because of this statement. 2 is once again less than 12, hence the control goes inside the loop, it prints the value of n because of the print statement. So you will get in the output the value 2. Next, n is plus plus 3. Once again the control goes back and 3 less than or equal to 12, hence the value of 3 is printed. So the repetition of this process will be continued when up to 12. When n plus plus 12 plus 1 becomes 13 and the control goes back here, 13 is less than or equal to 12, it fails. Immediately this control goes to the last statement printf/n. It comes out of the program. This is how you can use the while statement for a repetition of some of the statement which is there in the body of the loop until the condition is satisfied. So this is an example to demonstrate the repetition of the loop. Let us understand how you can use this loop in order to do some computation. The simple example to demonstrate this program is, I want to sum the value, sum equal to 1 plus 2 plus 3 plus up to 50 or any n number, up to whatever the number you are going to get, up to that one you have to sum it. So to start this process, let us take one variable, say n, initialized to 1, that is the starting point, and take another variable sum which is initialized to 0. This is the sum is the variable, keep tracks the summation of all these statements. I will put a condition while n less than or equal to 50, no semicolon here, you remember this point, put begin. The new value of sum which is equal to old value of sum plus whatever the value of n is there at that moment. First initially it is 1, sum is added with 0 plus 1, we got the first value summed to the variable. Now we will increment the value of n plus plus, it is nothing but n is equal to n plus 1. Instead of writing like that, you can also write like this. Then close this bracket, control goes back. Now it checks once again, n plus plus means the value of n now becomes 2, 2 less than 50, if it is true then the value of whatever the old value of sum is now 1, 1 plus 2 that is 3, the new value of sum now becomes 3, n plus plus it becomes 3, control goes back, 3 less than or equal to 50, if it is true, for the sum whatever value you have got in the previous step added with a new value 3, and 3 plus 3 you got 6. Next n become 4, 4 is less than 3, 6 plus 4, like that the process will continue until n reaches 50. Whenever the last sum whatever is there, that is 50 is added and the result is available in the variable sum. That's when it becomes, in the next iteration 50 plus 1 become 51, this condition fails. You come out of this loop, now you print the value of sum, printf sum equal to percentage d, because if you are going to declare this variable as integer type, you are going to put sum, close this. So in this way you can make the initialization of whatever the variable, condition to be enforced, the increment value, whatever the computation is there, like that you can repeat. You can complete this program, include whatever the requirement is there, include stdio.h. This is required because you are using printf statement. Here I am not using assigning all these values, use main int begin, you declare n and sum as integer, int n, int sum equal to 0, your program starts. While n less than or equal to 50, there is no semicolon here, remember this. Usually you will do this mistake by putting a semicolon here, there is no semicolon, begin and end, these two statements will repeat and the value of sum is printed. In order to see your result in the output until you are going to press a key, you can make use of one of the function that is called getch and end your program until you press a character, your result is available on the screen. If you do not want this statement, you have to press Alt key and as well as F5 key in the case of Turbo C. So you can avoid this by introducing this statement. Along with this, you are going to use one more statement, return 0. So in that, so you put semicolon. So return 0. Here when you use this function, you have to include one more header file that is called conio.h. Include conio.h, console input output. This statement acts as a console input, hence you are introducing conio.h. Like that you have completed your program with all necessary things. Sometimes in the Turbo C environment, the previous result also be available, whatever the computation is there, that is also available, the result, and the next whenever you run your program, that results also comes in the output. You do not want that should be available, and to make your cleaning of your output screen, you can introduce one more statement, that is clr scr. This is a built-in function, clear screen and put a bracket. Here this be after all your declaration statement or the variable declaration statement, you can call this function clr scr. This function is also available in the conio.h. So the previous output which are available on the screen, which will be washed out, and the new value of whatever you are going to give at that present, that will be available on the output screen. So these are the two extra statements you are now introducing to your program to make your program look fine. So anyway, you have done this 1 plus 2 plus 3 up to 50. So a small change. Let us start from 2 plus 4, 6 up to 50. What is the change is there in this statement is, it is starting from 2. At each iteration, instead of incrementing by 1, you have to increment it by 2, so that when the next value will be 4, next value will be 6. What is the change that can be adopted? Now, instead of initializing n is equal to 1, let us initialize to n is equal to 2. That is the first. Next, n less than or equal to 50, because here the last element is 50, this condition satisfies. No change is required. Sum is equal to sum plus n. What sum is already initialized to 0. 0 plus 2, it will take care of the first step. Now, instead of n plus plus, now 2 becomes 3 if you use n. Instead of that one, you can also use n is equal to n plus 2. Now, 2 becomes 4. Control goes back, 4 is less than 50, yes. So, 2, whichever the previous value is there, 2 plus 4, 6. Now, you got the result. N becomes 6, previously it was 4, now it becomes 4 plus 2, 6. So, this process repeats until n less than or equal to 50 condition satisfies. This statement you can also write in a short form, n plus equal to 2. This is also another way of replacing this part of the statement. If you want, you can use this statement, use this type of notation. So, this is the change that can be observed, the initialization part, condition part, repetition statement, and making this one condition, so you can go near to your repetition loop to be come out from the situation. So, what if you want here 2 square, 4 square, 6 square, 50 square, that is your equation. It starts from 2 square, 4 square. What are the changes that can be applied to the same program so that when you can get the value? Sum 2 square, 4 square. So, here 2, 4, 6 which are there in the same position. Now, instead of summing with n, you can call a function power function. You are familiar with a mathematical library, you can call a power function. Base is same 2, 4, that is n value. Each time it is incrementing by 2 only, hence 2. Put a power function at each time 2 square, next 4 square, that is added, 2 square, 4 square, that is added at every iteration the correspondingly until you are going to reach 50, that process repeat. When you call this function, you should remember this function is available in one more header file that should be included to your program, that is include math.h, that is mathematical library which is required because you are calling one of the built-in function, that is power function. So, this is math.h helps in calling the power function to compute this part and add to your previous value, the process repeat. This will not change much because your equation is says 2 square, 4 square, 2, 4, 6 only you are changing it out. So, this is the process. Now, a small change is if it is found in your equation, say 1 divided by 2 square, 1 divided by 4 square, 1 divided by 6 square, 1 divided by 50 square. Now, you observe your equation now is modified in your process, 1 divided by 2 square should be computed. Now, whenever you observe this is a numerator and denominator part. Numerator is same, whereas the denominator is changing. You are assigning to some value. Because there is a ratio is there, now sum is now becomes the floating value. If you declare it as integer value, you will not get the decimal part of it. The first thing you have to change, the sum should be, the data type of the sum should be changed to float, 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 and initialized to 0.0. That is the first observation you have to make here. Next, second point, 1 divided by 2 square is there. So, here anywhere the power function works correctly for, so here is plus 1 divided by power of n comma 2, it supports. Only a small observation you have to make here, this part is also integer, this is also integer, becomes integer division. Once again the decimal point will not be possible to take. You do a small change here, instead of taking 1, take 1.0 and compute it. Now, it has become mixed mode. You can remember it is integer, now it become float and it integer part. the result is become float and it is also float, your value will be get summed with your previous value and the result is obtained in the sum variable. While printing, you have to take care, instead of percentage d, you have to replace it by percentage f. The remaining things follows. So, like that you may find varieties of such mathematical statements in your mathematics that can be made possible for you to develop a program for the same. So, like that, let us observe some more programs in the usage of while loop for the same. This is 2 plus 4 plus 50 observed in this statement, n is equal to n plus 2. This is increment by 2 instead of 1, increment by 2. 2 square, 4 square up to 50 square. Here also the sum is equal to sum plus power of n comma 2, increment n by 1, it is not n by 1, it is n is equal to n plus 2 because each time you are incrementing by 2. 1 divided by 2 square, 2 by 4 square, 25 by 50 square. A change is, you can observe here, in this program you have taken numerator is same, whereas here numerator is also changing, 1, 2, 3 up to 25, the denominator now becomes 50 by 2. What is the change you can do for your program is, instead of keeping this variable, this term as a constant 1.0, you are going to change by m. You are going to initialize to 1.0, m divided by power of n comma 2, where m also you are incrementing in the loop along with n is equal to n plus 2, increment m is equal to m plus 2, that is increment of n by 2 and as well as m is equal to m plus 1. So, this process repeats. So, each time it becomes, first time it is 1, become 2, 4, like that, 3, 4, like that it will increase. At the same time you are going to compute n square, 2 square, 4 square and the computed value will be added to sum, resulting your variable is available. Remember, now sum value is 0, remember to use here, instead of percentage d, here you have to use percentage f, that is the change you have to do. I have put here percentage d. If you use percentage d, your result will not be completely observed. So, because now it becomes an integer value, decimal part will not be observed. Replace this percentage d by percentage f to get exact value. That is how you can see the difference between the need of floating variable and integer variable in the programming. Another interesting program is how to calculate the greatest common divisor of two numbers. That is, let us say you are going to take two numbers m and n. How to find out the greatest common divisor among these two numbers? So, there is a method given by Euclid's algorithm. If there are two numbers which are given, say m and n, 50, 35. Among 50 and 35, if we give 50 and 35 as the data, the greatest common divisor for 50 and 35 is 5. How to compute this process? In the first step, let us assign the value of m 50 and n equal to 35. Your interesting operator, you are familiar with this operator, that is percentage operator, that is called modulus operator. That is, you are going to get the remainder of m mod n results in whatever the remainder comes, that will be available when you use this expression. So, 50 divided by 35, so resulting the remainder whatever it is obtained is 15. This 15 you are going to assign to n and 35 you are going to assign to m. The value of n you are passed to m, and whatever the remainder you are going to get, that remainder you are going to pass to n. So, the new value of m becomes 35 and new value of n is now become 15. 35 divided by 15. So, when you divide it, 15 2s are 30, the remainder left out is 5, that is available in this variable 5. Now, once again pass 15 to m, then m becomes 15. Pass the remainder value to n, n becomes 5, that is the third step. 15 by 5, when you divide it, 5 3s are 15, resulting the remainder becomes 0. When the remainder becomes 0, whatever the value which is there for the n, that itself is the GCD of m and n. Pass to m and get the value, print the value of m, you are able to get your result. So, this is the process. So, how to develop the logic for this? You are all familiar with using of while loop, and the process of developing this logic can be observed like this. Now, you observe, first you are going to read the value of m and n. Remember, the value of m should be greater than n. That is the first observation you have to do, m and n, that is 50 and 35. While n greater than 0, when you are gone dividing, at some time the value of n becomes 0. Until this value becomes 0, n greater than 0, repeat the process. Which are all the statement? Get the remainder, r equal to m mod n, that is 50 mod 35. This is the statement. So, you get the value of r is the first r equal to m mod n. After this, pass the value of n to m, n is assigned to m, n is assigned to m. Next, assign the value of r to n. So, r value is assigned, that is the stack, this whatever the remainder you got, that is assigned to n. You should not change this statement, you should be in the same order. If you do first n is equal to r and m is equal to, you are going to lose the value of n. Remember this, first assign n equal to m, then assign r value to n. So, once again the control goes back, check for whether n is greater than 0. If it is true, then it repeats the same, it get the new value of m and n, for which you are going to get the remainder. So, this process repeats until this condition n greater than 0 condition is there, the value will be available, the process will be repeated. The value of m will be the GCD of two numbers what you are going to take, that value is available in the m value, you print it. GCD of m and n is the value of m. That is, in the program, the logic you understood. In the programming statement, observe r, m and n and r, these three variables you are declare it as int. Printf, enter two integer numbers, that is scanf %d, ampersand m, ampersand n. While n greater than 0, r equal to m mod n is the same thing, you are going to get by making use of modulus operator, m equal to n equal to r. Printf GCD of m and n is %d m value. So, m going to keep the result at the last iteration, the m will be having the GCD of m and n, you print that variable, return 0. So, this process in the output you will get the values of any value that you are going to supply two numbers. At that, while giving the data, you should be careful that the first m should be greater than n. So, if it is if you are going to give m value less than n, then you have to exchange these two variable and swap these two variable, and your process repeats. That is the change you have to do. For the time being, let us assume m value should be greater than n, this program works. So, try this experiment. Here we used while loop in order to develop our logic. So, this is the usage of while. So, there is another interesting statement that is called do while, a small change in it. So, you understood while statement where the condition is checked initially, whereas another interesting control statement is do statements, all these statements do until, that is while condition is there. Here while condition is put at the end. So, there is a semicolon here, that is, you remember that do while condition, there is a semicolon. So, here these statements whatever it is there inside the loop, that should be repeated until the condition is fulfilled. Here this is called entry is free, whereas at the end, in order to go back to the loop, once again the condition is checked, whereas in the while condition you are going to check the condition first and then you are going to, if the condition is true, you go to the loop. So, this is the change that you can observe between the two interesting statement while and as well as repetition. So, this is the general structure of while statement. Do statement, do is the first keyword, begin, step 1, all these statements will be there. end of end, begin and end, the block of statement. Step 2, control comes here. Here the condition is checked. If the condition is true while I less than 10, it goes back. If the I less than 10 condition fails, or whatever the condition you are going to enforce while, then it will go out of the loop. That's why this statement is called exit controlled, whereas while statement is called entry controlled. While entering into the loop, it is controlled through the condition. Here, while before exit, the condition is checked, for which exit control statement. So this is the general statement. You can observe initialization of variable, do is the keyword, begin and end, while condition semicolon. You remember this semicolon is required here, whereas in the while condition you should not use semicolon. So this is the two differences you can observe. All whatever you understood, the same thing repeats here also. You can observe one small program to demonstrate, to print in the output hello 10, hello 9. Observe, it starts from 10 until you are going to reach 1, the output should display like this, hello 9, hello 10, like that up to 1. So how we can use do statement? Observe this, int I equal to 10. Initially the value of I is initialized to 10, because you have to print first 10, that's why you are initializing to 10. Do printf in the double quote %d the value of I is now 10, hello 10 is printed, hello 10. Because of /n, it goes to the next line and prints the value of next variable. Before going to the loop, you are changing value of I. Instead of here I is equal to I minus 1, 10 now becomes 9. Is 9 greater than 0? Is it true? Once again the control goes back to the do loop, print the value of this hello. Here the value of I is 9, hence hello 9 is printed. /n, it goes to the next. After printing 9, next printing will be done in the new line. So this process repeat until this condition is fulfilled. That is, so this is the do while statement support with respect to while. Whatever the program you understood, you can be transferred to do while. Only the condition and the corresponding initialization that should be trapped. Let us move on to another interesting laboratory experiment which is there in your lab, that's supposed to be completed. So here the experiment says, it will give a number, any number as such. You have to check whether the given number is palindrome or not. What is a palindrome? When you take a number, say 1221, I will give a number 1221. Reverse this number. If you reverse, then also you will get 1221. Any number, when it is get reversed, then also the same number if you are going to get, then that number is called a palindrome. If the given number and its reverse is also same, then the given number is called palindrome. User will give a number, you have to print whether the given number is palindrome or not. That is, the output is required for this program. How to develop this logic? You can use while loop or do while statement in your program. Using while loop, this program is developed. So for initial, let us the user give a number. You will understand the steps which are required. 3467, it is the number given by the user. First you have to reverse this number. A simple logic that can be used. First divide this number by 10, integer division. When you divide this number 10, you will get 346.7. When you do using modulus operator, if you do, whatever the remainder is that you can catch. That is 3467 divided by 10. Observe this, digit is equal to num mod 10. So whatever the number you have read, that is mod remainder part you can get using this step. Digit is equal to num mod 10. That is the last digit is 7 that you got into the reverse. So one simple logic that can be used. Whatever the reverse is there, old value of reverse, initially you are going to initialize the reverse to 0. Reverse is multiplied with 10. 0 into 10 becomes 0 plus digit 0 plus 7, 7. That is the reverse equation, reverse value. So that is how you got the first reverse value is 7. When you do in num, now you are changing num is equal to num by 10. 3467 divided by 10, because of the integer division, now the value is now become 346. The new value of num becomes 346. So here will come 346 not equal to 0. If it is true, 346 mod 10, you are going to get 6, because 346 mod 10, the remainder is 6 that you got. Now whatever the digit you got, for that digit add to previous reverse number. Reverse number now is 7. 7 is multiplied with 10 becomes 70, plus the new digit is 6, 76, that is assigned to reverse, and the new value is now become 76. So once again the control goes back. At that time 346 divided by 10 becomes 34. It is not equal to 0. Hence 34 mod 10, 34 mod 10, you will get the remainder 4. So you will get 704, that is reverse 76 into 10, 760 plus 4, 764. So this is how your reverse number is growing. Now once again you go back and you say the 34 now becomes 3 digit, you will get the remainder 3, and number 3 divided by 10, number becomes 0. So whereas the 3 is get added to your reverse previous number, 764 into 10, 7640 plus 3, 70643. That is how you got the original value is 3467 and reverse number is 7643. So at that time the value of number now becomes 0, because of num is equal to num by 10. It is an integer division. Remember this, num is also integer, hence the integer division 3/10 becomes num becomes 0. Control goes back here, whether num not equal to 0, no num is 0, control goes out of the loop. So now when you come this, you will be having the reverse number in this variable reverse, that is 7643. Now before going to the loop, let us assign the original number, whatever you read, that will be assigned to variable temp. Temp is also another variable. So your original number 3467 is now available in the temp variable, whereas inside the loop you have modified the num becomes 0, whereas your original number is available in this temp. Now you can use our if condition. If reverse value, whatever you got the reverse number, if it is equal to the original number that is available in the temp, if this condition is true, print it is a palindrome, that is given number is a palindrome. In this case 7643 is not equal to 3467, hence this condition will not work, and say printf given number is not a palindrome. That is how you will get not a palindrome result. So whereas when you give the number 343, the same logic apply, 343 remainder 3, the last digit, that is the remainder will get 3. In the next step the 3 is get reverse number is now becomes 3. In the next step 3 is multiplied with 10, 30 plus 4, that is 43. Next 3, once again the remainder 3 you got, so 343. So the original number is 343 and the reverse number is also 343. You know your number now becomes 0, because of this control goes out, and the temporary variable before you go to the loop you are assigned to 343 here. Reverse number and the temporary variable both are same, hence you are going to get in the output the given number is a palindrome. It is a very interesting program through which you have learned how to use while loop, putting the condition, initialization, the changing using all our computational statement, and get the result based on our requirement. This is how you can understand and execute this program in the laboratory to get the result of how to check for a palindrome. In order to make interesting, there is an interesting number is there in the mathematics, that is called Armstrong number. What is this Armstrong number? Definition says like, those numbers which sum of the cube of its digits is equal to that of number are known as Armstrong number. For example, if I give 153, that is 1 cube plus 5 cube plus 3 cube, each digit and its cube. When you add all these numbers, 1 plus 125 plus 9, then if you add this number you are going to get the same number what we are given. any number which satisfies this condition after cubing of this number, and if it comes the original number itself, then you can say that given number is a Armstrong. User will give a number, you have to print whether the given number is a Armstrong number or not. That is the question for which you have to develop the logic. The same logic whatever you understood for a palindrome, that can be extended now. So if you observe this, the variable num, whatever you are going to read it, or that is r variable, sum initialized to 0, one temporary variable, enter a number, whatever the number, 153. So you have got that number by making use of scanf statement. You can read this variable scanf %d ampersand num. So assign num to temporary, keep this number in one variable, you require this number to check at the end, just similar to palindrome checking. For that reason you are going to keep your original number in another variable temp, which is also of type integer. So this is how you have got your original number available here. While number not equal to 0, take the remainder num mod 10, you got the remainder, that is last one, 3 cube. Num is equal to num by 10. Now number 153 divided by 10 becomes 15. Now number becomes 15. Before going to the loop, you do this sum is equal to sum plus r cube. Whatever the digit you got, that is 3, you get the cube of is 3 cube. Go back, get now number is now 15. 15 mod 10, you will get 5 as the remainder, 5 cube. Add to the previous number, that is why sum is equal to sum plus 5 cube. So 3 cube plus 5 cube, whatever the result is available, that is available here. Once again go back, take that number 1 mod 10, the remainder whatever it is available 1, you take the cube of this, using this 1 cube is added, at that time 1 divided by 10, the number becomes 0. Because this condition fails, the control goes out of the loop. Your original number is available in the temp variable. Compare the sum with temp. If it is both are same, that is 153 equal to 153 original number, print given number is Armstrong number. Otherwise it is not a Armstrong number. Like that you can develop the logic for mathematical statement based on the conditions which are required, which are the statement that should be get repeated, that can be enforced between this begin and end, that can be done. Which are all the statement we have observed now. While can also be replaced using do while statement. The changes that what you observed is the condition should be put at the end, semicolon should be placed, whereas here there is no semicolon, remember this point, and the increment or a decrement whatever it is there, that should be done inside the loop, initialization outside. So this is how you can best utilize these two interesting statements in the programming. So let us go to the next for statement. You are understood up to now the repetition of the statement using while loop, do while loop. Another statement which is very much useful for the remaining part of the program to make our programming easier is a for statement. Here instead of while loop, you are while keyword, you are having for keyword. Initialization, increment and condition, these are the three statements which are required for any of the repetition. Here all these statements are put inside the bracket in a single statement. Initialization of the expression, the condition that is the final expression, and updation that is increment or decrement. Based on this, the expression is once again checked. If it is true, goes inside the loop. Otherwise, if the condition fails, goes outside the loop. So this is how we can observe for is the keyword, open parenthesis, initialization, semicolon, expression that is the final expression, semicolon, that is increment or decrement, we call it updating of the expression, putting there is no semicolon here. Remember here also there is no even though always you will forget this and put a semicolon. Compiler will not give a error for this, where you will not get your result properly. That is why remember while and a for, that at the end of the statement don't use semicolon. Begin and end, these are all the block of statement that should be repeated until this condition is true. So one example, now you observe this, for I is equal to 1 semicolon, I less than or equal to 10, I semicolon, I plus plus. initialization, the condition whatever it is there in the loop, inside the loop I is equal to I plus 1. How it works? Initially after initialization, check for the condition. If it is true, inside the loop it executes and update this value, checks for the condition. If it is true, control goes inside and repeat this loop. Let us observe through a graph how this statement looks. The syntax of the for loop, look, for is the keyword, inside the bracket, that is inside the bracket, initialization part, semicolon, condition, semicolon, iteration or updation, whatever it is there, body of the loop, begin and end. This is the general structure of a for loop. If you look in pictorially, for is the keyword, open bracket, I is equal to 0, that is the first step. After this, the control goes here, check for the condition whether I less than 10 is true. If it is true, observe this, step 2 is this, it goes inside the loop, execute all these statements and control goes back here where the increment and decrement you should not do. It should be done in this position where the iteration step which is required, I plus plus. In the previous while loop we have done here I plus plus, but whereas here I plus plus or decrement or updation is done in this position. That is called step 4. After step 4, the control goes back here and check for the condition. If it is true, it once again goes inside the loop, that is step 2. If the condition false, it goes outside the loop. Here also it is called entry control because after the initialization, if the condition is true, it goes inside. Whereas in the do statement, this condition is checked at the end. That's why it is called exit control. Whereas this statement, entry is controlled through this statement, the process is get repeated. So this is an interesting for loop through which all our programming can be made very simple by introducing this statement. Let us understand the same programs that what you understood this for loop. So here sum equal to 1 plus 3 plus 6 plus up to n. Whatever the user gives the value of n, up to n you have to sum this series. So using for loop you can develop the logic like this. Anywhere the initialization variable is required, I use I variable, I equal to 1. Let us take one initialization variable that will be incremented at every step until you are going to reach the value of n. While I less than or equal to n, this is the statement that you are going to use while loop. Here instead of this you are going to use for statement like this. For, instead of initializing here I is equal to 1, you can initialize here itself, that is I equal to 1, that is initialization is over. What is the condition? Until I less than or equal to n. If the n value is say 50, you can check here I less than or equal to 50, that is the condition. At each time the value of I is incremented by 2, 1, 3, 3 plus 2, now it becomes 3 plus 1 plus 3, 3 plus 2, 5, 5 plus 2, 7, like that. If it is the condition is like this, then I value is initially 1, when it is added 2 it becomes 3, added 2 becomes 5. So I plus equal to 2. You can also put I is equal to I plus 2. Begin, initialize the sum variable to 0. Sum equal to sum plus I, that's all. End of this. Observe this, I is equal to 1, sum is equal to 0 plus 1. In the next iteration I becomes added with 2, I becomes 3, 1 is added with 3, the result 4 is available. This process will be repeat until this condition is true. So all the 3 statements which are required in the while loop, everything is embedded in the single statement. One important information you should observe is you should not change the value of I here. At any time you should not change the value of I by adding something or anything, any value to it. You should not update. It should be updated automatically here. That is one information you should always remember in the while using this. Whichever the variable that you use inside the for loop, that should be increment or decrement, or the updation should be done here, not inside the body of the loop. That is one step you should always remember while using for statement. Like that, you can use this for statement to compute any of our previous program, that whatever you observed through a small changes in the programming. Initial expression is usually an assignment expression. Update expression is usually an increment or a decrement expression. The final expression is the relational expression, results in true or false. Based on this true or false, your process of repetition works. So this is how you can use for loop. One example. Print the numbers in the given range, say up to m to n. I will give the m value say 10, n value say 50, up m to n the value should be printed. Initialize I is equal to m, I less than or equal to n, I plus plus percentage d slash t, that can be used to use space in the output. Print the value of I. So I value will be printed from the starting to final value at a step of 1, because you are incrementing by 1. This is how a simple statement of for loop that can be used in order to get your results. You can also use, observe this, x is equal to 0.1, x less than or equal to 1.0, x is incremented by 0.2, that is at each time it is incremented by 2, and here while printing a small change, percentage f along with the s, x and its square can also be printed, x star x. Percentage f slash t, a small gap will be maintained here, and its square that can be printed, x square, that is 0.01. So this process repeat. Initially 0.1, 0.01 is printed, x is incremented by 0.2 is added to previous one, now become 0.3, that is why the value of x now becomes 0.3, and then its increment value x square, that is 0.09 will be printed. Like that, you can also use a floating variable here in order to use in our programming. Here slash n helps in printing. After printing the first line, your output will be printed in the next line. So the remaining part of the program that can be added to generate this list on the output. This process will be repeated until 0.9, because after 0.9 when you add 0.2 to it becomes more than 1.0, hence the control goes out only up to this 0.9, it prints on the output. This is how you can take the control over printing, increment or updation here, and this. You can also use decrement whenever it is required. So this is how you can develop a logic of this. Let us understand how to develop to calculate the factorial of a given number. So whenever you say a factorial of a number, in mathematics you are familiar, the factorial of a number, n factorial, which is equal to n into n minus 1 into n minus 2 n minus 1 up to 1. So this is the general formula, you are all familiar, or 1 into 2 into 3 up to n. When you are going to multiply, you are going to get the factorial. Say example, 4 factorial means 4 into 3 into 2 into 1. That is the whatever the result you are going to get, that will be the factorial of a given number. And one more observation is you have to make is, that is, in order to develop this logic, the factorial is defined only for the positive number, it is not for the negative number. N should be always greater than 0. That is, how to develop this logic? You can make use of one variable, say factorial variable, initialized to 1. Anywhere the user will give the value of n, let us assign n equal to 4 for this case. Here for loop, you can initialize your variable, starts from initialize I equal to n, assign the value of n2 because it starts from 4, I less than or equal to 1, less than or equal to 1, I minus minus, I minus minus. Inside the loop, whatever the value is there fact, the new value of fact is calculated by multiplying with I. Observe this, first initially the value of I is 4, hence 1 is multiplied with 4, that is the result you got. The value of I now becomes decremented, it becomes 3. Is it 3 less than or equal to 1? Yes, the control goes inside. Now the previous result, whatever 4 is there, now it is multiplied with 3, 4 into 3, 12, that result is available to you in this variable. The control goes back and decrement the value of I, now I value become 2 because previously it was 3, now it is 2. 2 is get multiplied with 12, 12 into 2, 24. And control goes back, I becomes 1, I less than, since you have written equal to 1, it is true, that is why the 24 is get multiplied with 1, the result 24 is available. I is now becomes minus minus, now this condition fails because it is now become negative, the condition fails. Take the control outside the loop and print the value of, printf the value of factorial equal to percentage d, and the result is available in this variable, you print it. So this is a simple logic that can, whatever you understood, that can be trapped out. You can also in the reverse also you can write 1 into 2 into 3. The changes that to be done is I is equal to 1, I less than or equal to n, I plus plus. You can also use the downward logic or as well as the forward logic, depends upon the situation. In this program, observe this, all this whatever it is there, it is completed with all respect, that is main, int, n, I, fact, all these variable you are going to initialize the variable int n, fact is initialized to 1, enter a positive number. This is the message you should give. If the user gives a negative number, you cannot check. For factorial, you cannot calculate the factorial of a negative number. Tell the user to give a positive number. Scanf, double quote, percentage d, ampersand n, because now you are reading the way n value. For I is equal to n, I you are going to initialize to n, I less than or equal to 2 or 1, because anywhere the last multiplication with the 1 you will not change your result. You can stop at 2 itself. I minus minus, even if you give 1 here, it works. One multiplication that can be reduced multiplication when you want to put a condition I less than or equal to 2. Fact is equal to fact into I, that is the step that you have to observe. So this fact into I, here I have not put a begin and end because the only one statement that should be repeated. So fact into I, and the print of the factorial of percentage d, the number n, and the result is available in the variable fact. That so that process is repeated, factorial calculation at the end. A given number is a number and its factorial is printed on the output. This is how you can use your for loop in your programming. You can use in the forward fashion or in the backward fashion. Depends on the problem domain, you can change accordingly and best utilize the factorial of a given number for your process. So the for loop is a very flexible construct. It can be used for decrementing the counter. Example, n count is a variable initialized to 0 until greater than 0, n count minus minus. This is one way of downward, or you can also use upward counter initialized to 0 until this condition is to increment value. Like that you can use, that depends on your situation, any situation that can be applied by incrementing or decrementing the variables. So this is an interesting for loop which is available in the programming. Let us understand more of the syntax and its usage in the programming. So up to now whatever you understood is all the basic control statement, such as if condition you understood, the nesting of the if condition you understood. Later we have moved to repetition of some of the statement for process for which the while loop, do while loop and for loop. So these three statements you can replace one by another and you can get the same output, but while replacing you have to take care of the corresponding condition, initialization and increment in your process to get your results. Let us understand in the next hour how you can use this programming principle for utilizing through some of other programs which are prescribed for the laboratory exercise to do it.